Hi everyone. Welcome to Tech Talks at DevBytes, where we decode the tech future one byte at a time. If you are here, it means you are either a tech enthusiast, a developer, or maybe just your AI overlord has recommended this video for you. Thank you for joining in. And Today we are exploring distributed architecture, essentially edge computing and everything that's related to all that. And because if you're not thinking about this yet, your competitors or your peers definitely are. For taking you along this ride, today we have Jay Jenkins, CTO at Akamai, and who has graciously accepted our invitation and is available at 9:30 p.m. in his local time. So thanks a lot, Jay, for coming on our platform and enlightening our viewers about what's going on and kind of having the right discussion that everybody is now talking about. Folks, whether you are coding right now or just lurking or still debugging that problem, that one issue that was given to you yesterday, stick around because it's going to be worth it. Jay, welcome and thanks a lot for joining in. Uh, and let's start with a little bit of introduction about you by
Great. Thanks, Ramesh, and thank you so much to DevBytes for inviting me to participate in this talk. So yeah, my name's Jay Jenkins. As you mentioned, I'm the CTO for cloud computing at Akamai. I've been with Akamai for a couple of years now. Before then, I was with ByteDance for a brief time, and before that, I was with Google Cloud for almost 9 years. So sort of there from the beginning of cloud computing as we know it, and now looking at the future of what cloud might be. So it's a really exciting time.
that's so great. I mean, first Google Cloud, then ByteDance, and now Akamai. So, what has been the one key learning, or I would say the driving force that has propelled you in this direction?
Yeah, it's interesting, right? I mean, I think for anybody, when you look back at your career, it's sort of like a series of happy circumstances and opportunities and decisions that you made along the way. And some of them work out, and some of them don't work out. I think overall, I've been very lucky that these decisions have worked out. But I think along with that comes, quite a bit of natural curiosity, which sort of led me in this direction. When I was at university, University of Missouri in the U.S., I actually left and joined a .com. So after a couple of years university, decided, there was a lot happening in tech at the time. Joined a .com in tech support. It was a different time. They gave me
It
like
was a different
12
time.
weeks. I know. Yeah, but they gave me like 12 weeks of training before I, even started because, there were a lot of new technologies at the time, and they pretty much had to train you because, you really didn't get the types of education that you do today at university. Tech support, then went into quality assurance, then went into consulting. Did consulting for a good 9 years, and I learned a lot in that time. It gave me an opportunity to work with many different companies across many different industries, and I got exposed to a lot of technologies and domains that I would have otherwise not had an opportunity to do. I then joined a smaller consulting company where I was an associate partner. That company got acquired. I decided to use that time to go back and educate myself. So I went and got my master's degree in business. At the same time, I was overseeing an offshore development center in Vietnam. So I did that for a couple of years. And then I had a big opportunity, consulting opportunity at a bank in Singapore. So I moved there. Then, after about a year, went to work for Google, Google Cloud. That was a purposeful decision. I actually was interviewing at a couple of different cloud companies, but I made a decision specifically to go into cloud because I thought, that was definitely going to be the future. and it was really interesting technology, and it's was the foundation of something I believe in, and I still believe in, even though that vision has sort of changed over the years. So yeah, it's been a really interesting journey, but certainly conscious choices to really figure out, what the next wave of interesting technology was going to be.
Right, and I mean, cloud has been, by the time, if I'm not wrong, by the time you probably joined your business school, the cloud was already booming with AWS leading the pack in a certain sense, right? And it was a very interesting time to be around in cloud. And I'm pretty sure you must have came across a lot of different architectures during that period.
Yeah, yeah, absolutely. And again, the patterns have changed quite a bit, right? I think that, I mean, if you take a look at Google Cloud as an example, when I joined, really the two major components of cloud at Google at the time were App Engine and cloud storage. Uh, Virtual machines had only just launched when I started at Google Cloud, even though AWS had them before. And I think that was a big sort of turning point for Google because they expected everybody to really embrace sort of more platform as a service and serverless architectures, but the world kind of wasn't ready for that. And AWS provided virtual machines, so Google had to step back and move to virtual machines because people just wanted to lift and shift what they had today into the cloud. But once they did that, obviously now you have a lot of what people consider cloud native architectures, really enabled by containerization. And you see Google, really uh, doing a lot in that space when they released Kubernetes as an open source project, and that really propelled the entire industry forward because it provided so much automation around containers. So now, as organizations continue to embrace more cloud native architectures, along with that come new complexities, complexities that still need to be solved for as people use Kubernetes not just as a platform for applications, but a platform for other platforms. And it's just layers and layers of complexity. And along with that, you have this whole idea of shifting left with security, which puts a lot of pressure on developers. You have DevOps, DevSecOps, FinOps, a lot of complexity and things to worry about as these more complex architectures come together.
Right, and essentially speaking, as more and more automation is coming into the play, it's becoming even more challenging on how to manage different automations. I mean, so how I mean, it's kind of really transforming, right? How the because of these evolutions that are happening in architecture, a lot of applications are also now changing again because of the traffic, the load, the scale that everybody is ramping up. For example, I mean, say for example, the streaming video technology. Initially, it used to be just files getting downloaded on your devices directly, and players used to do the video players used to do a lot of buffering, variety of techniques for buffering. But now everything has changed dramatically with live streaming shows like this one being scaled to multiple millions of people. So, I mean, like, what are the transformation and evolution? What are the transformations in this evolution that you kind of have seen that is kind of changing the narrative these days?
Yeah, well, it's interesting, when I think about how some of these architectures are changing, and I think streaming video is a really good example because it is something that is it's really about sort of like a one-to-many type of service, right? Where you're really trying to reach a bunch of users globally with something that is very heavy in bandwidth. And that's kind of Akamai's heritage, right? So 25 years ago, Akamai invented the CDN, the Content Delivery Network. And over time, that content delivery network, other things have to be installed at these edges as well. So it's not only a content cache, it's also your first point of protection for DDoS, as an example, or a web application firewall, all sort of managed at the edge. And the edge of the network really gives you a lot of resiliency. It gives you a lot of capability to reduce latency, not just for things like video, but other types of architectures as well. And that's really what Akamai is talking to its customers about today. It really is about what else can we do with this edge capability. Maybe it's not just about content anymore. Maybe it's about data. Maybe it's about processing at the edge, or maybe it's about AI at the edge. There are all sorts of new technologies, so things like AR and VR, which are pushing that along. But we believe that those are just really early adopters. Over time, it will go beyond just AR, VR, gaming, and media. And you'll see other organizations that are really more customer focused or want to stop thinking about where data is stored and think about where data is created in order to react to that in more real-time ways to give new and different kinds of experiences.
So, talking about this, I mean, what should that developers today be thinking about? How to really kind of transition into this evolving, or how to be prepared? Because at the end of the day, an organization has to move into this, and organization has its own challenges. But as a developer, as a practitioner, what would you kind of recommend for them to be prepared for this journey?
Yeah, well, certainly, I think developers need to sort of understand it and understand how it works. I think even though a lot of cloud native technologies are being used, in terms of the topology or how those applications get deployed are actually still quite monolithic in nature. So it's sort of modular but monolithic, so modulithic, if you will. Uh, but that's not sort of like the best implementation of these types of technologies, right? One of the purposes around microservices is you should be able to sort of put those microservices where they belong, run them close to the data that it needs to work on, or run it close to the type of processor that it needs to run on, or run it close to a device, an autonomous vehicle, or an end user, if that's what makes sense. I guess the question, though, that a lot of us are asking ourselves is that something that a developer should necessarily even worry about? Or is that something that should be automated for them in some way? Or is there a particular team that might be in charge of that instead? And in that case, maybe we need to think about different ways that our teams are organized. And you see a lot of organizations already doing this already with cloud native applications through platform engineering teams. So platform engineering teams are a big topic, in particular among large organizations, but even with small organizations, the amount of expertise required to manage that complexity, manage the security, manage that platform of platforms. So, a lot of these organizations are running other things on top of Kubernetes, right? Whether it be Istio or Cilium or Argo or Kyvernos, all of those things require certain levels of expertise. And perhaps it's something that the application developer shouldn't have to worry about. But if you give them that model for deployment, where they can just have their container, have their service, and you have a platform engineering team that then understands the best place to run that and the best way to run that, it helps abstract that away quite a bit. And it has a good amount of separation of concerns and separation of skills and capability.
That's even more tricky in a certain sense. So for the uninitiated, let's just jump back a little bit and kind of quickly maybe take over take them talk a bit about the difference between cloud and edge computing a bit, because we actually have a lot of different developers as our audience in various levels or years of experience. So why don't we touch a bit about that first?
Okay, great. Yeah, look, edge computing is, today quite an overloaded term, really. I think a lot of people think about edge computing in very different ways. Like, is my phone an edge device? Certainly, it could be considered an edge device. I think where Akamai is concerned, whenever we're thinking about edge, it's really about what we call the access edge, essentially the edge of the network. So that things that are still under control of like another vendor. So for us, globally, we have 4,100 points of presence, and those points of presence exist in local ISPs all over the world. So For us, it's really about getting right up until at the edge of the network. For some, edge can mean on-premise devices. It can mean the device itself. It can mean an autonomous vehicle or a car. All those things are also edge devices, but those things need to be enabled in very different ways.
Right. So essentially, applications, or if we talk about use cases, they would start ranging wherein edge computing is all about managing things. The
Yeah,
applications are changing, right? From IoTs to uh, maybe your VR headsets, or like you said, autonomous vehicles. And these things are actually quite catching up on. But I'm pretty sure there would be a lot many more use cases that you must have come across.
yeah, definitely. I think when people look at even cloud native architectures today, they still think of things in very much like this client server sort of way. I've got my phone as a client, or that IoT device as a client, and it connects to a server. The way we think about edge and distributed computing is exactly that. It's more distributed. It's more continuous. So it's a continuum of compute from a core data center all the way to the edge. And the idea is to run that process where it makes the most sense to run. I think a VR headset is a really good example, because a lot of the feedback from consumers is these headsets are just too big. They're too heavy. Like, I don't want to wear this thing on my face. The amount of compute that's required is massive, and therefore these headsets are required. But imagine if we could actually offload the compute to an edge access network. An edge access network can have single-digit millisecond latency, so you can still have great user experiences with a VR headset. But in today's world, number one, those edge access points aren't enabled for that type of activity. But also, people aren't really thinking, and developers aren't really thinking about things in that way, because let's face it, it adds a layer of complexity, and it's just simpler to think about things in a client server term. So I need low latency, I need single digit latency, I'll do it on a device. If I am okay with 40 millisecond to 100 millisecond latency, I'll do it at a core data center. So really thinking about things differently and thinking about this as a continuum of compute gives us a lot more options. You asked about other types of use cases. A good example would be a very typical e-commerce application. So a lot of the customers that we're talking to are e-commerce and retail companies. If you take a look at how they operate, they might have one of our customers, is operational across 7 data centers across the world. But they also do work away from those data centers. And let's say I have an e-commerce website in Vietnam. That data center might be in Singapore. Now, while 40 milliseconds might not seem like a lot, if you're doing that multiple times, it can actually degrade that customer experience, right? So the experience of a customer in Singapore is different than the experience of a customer in Vietnam. And I don't think that should be the case for a digital experience. The whole
Absolutely.
idea of an internet and digital experiences is you should be able to provide these same experiences to anybody, anywhere in the world. So imagine, again, sort of an e-commerce web app. So a common pattern in an e-commerce site is server-side rendering, where parts of the page are actually rendered on the server, so you don't overload that customer's web browser, so they don't have to wait for that web page to paint.
Right.
Now, today, that's done at a core website, and possibly, in fact, very likely, they also have like some sort of memory cache, like Redis, sitting there, so they can cache those page draws. Now, people generally use things like Redis in order to accelerate the database, or accelerate an aggregation of different services, so you don't have to make those calls again and again and again. But imagine if you could take that cache and move that all the way to an edge location. So now all of a sudden, your server-side rendering can take place very, very close to the user and improve their experience significantly. Now, by doing that, not only do you improve the customer experience, but you also increase your search engine optimization, because uh, contextual paints are a large part of how you rank on websites. So
Absolutely.
it's on search engines, I should say. So it's a large part of how you rank on search engines. So great for the search engine. It's great for you and your business because you have more discoverability, and it's great for your customers because they have this new and better experience that is similar to what you get in a large metro area that might have the luxury of having a large data center there.
Right. And in a way, it also allows you to kind of reduce your compute load on a single cluster or a centralized cluster. That way, if you are powering personalized experiences or region geographically personalized experiences, it just starts to simplify response times to the next extent. Next extent.
That's right. Yeah. So if you have like an 80% cache hit ratio on your server side rendering, that's now delivered at the edge, and you don't have to go all the way back to your core data center and pay horrendous egress costs to pull that 80% of the time.
But this is another important point I kind of wanted to touch upon. Whereas whenever we are talking about compute at the edge or edge computing in short, um, um, there would be a lot of synchronization of data that will start happening. And now, won't it start becoming costlier for the application or organization?
Yeah. So I mean, that's certainly something you think a lot about when you're thinking about these architectures. And I think that for many of the people watching, they'll realize that there are actually new and better choices for distributed data than there were even 3 years ago. So you really need to think about moving away from centralized data even, and thinking about how you're going to distribute data. Perhaps some of the data never needs to be centralized. You can just keep it at the edge and reduce costs. Perhaps and again, the distributed data, you won't have to wear the cost of going to that centralized database and exporting that again to the edge. So you have this capability to think about, how your data is going to be distributed globally, whether it needs to be stored centrally ever again, or whether that data needs to be stored centrally for compliance purposes or redundancy purposes or for training later on for your AI models.
Right. So in a way, kind of not just about the data in a certain sense. Sometimes it's also about extracting insights rather than keeping the data, and that would also, that's in my opinion, but that would also kind of reduce your inference costs or compute costs or bandwidth costs, and I'm pretty sure it will also introduce kind of a tiered pricing within the bandwidth in a certain sense.
Yeah, that's right. So I mean, I think anybody that's had to do FinOps or has had to look at the bill for their cloud, and they are a customer-facing application, they understand the huge amounts of egress costs. And I think, and I believe that a lot of the cloud pricing we have today actually restricts architectures and is actually stopping us from realizing this distributed computing model because of these large egress costs. Even within a provider, going from one zone to another costs money. Going from one region to another costs money. And then you have going from a region to your customer. Again, it costs money. And these aren't small prices, right? So, 5 to 10 cents per gigabyte is a lot. At Akamai, it's one of the things that we think about as well. I mean, luckily for us, we have this huge global network and a network of partners, and we're able to have very low egress costs. So instead of having 5 cents per gigabyte, we have half a cent per gigabyte. And it really allows our customers to revisit those models and think about how they might implement distributed compute to save on those egress costs. And but that in itself also causes complexity, right? From a FinOps perspective, because now you need to think about where you're going to run the VMs, how much does it cost on your hyperscaler, where you might have a managed service you have to use, or a proprietary service you might have to use, versus running it somewhere else, versus maybe moving to an open source platform instead of a managed service, or what is the egress cost to the edge versus the edge to the user, right? So it's more cost now involved and a little bit more complexity involved. But I do think that there are additional pressures now on hyperscalers to bring down egress costs in particular. You see it a lot in the EU, but hopefully, that pressure will expand to the rest of the globe as well.
Exactly, and so this kind of also so there is a question from one of our viewers, Bhavna. So I kind of it's related with what we just discussed right now. Like, in what ways can edge computing revolutionize industries such as healthcare, autonomous vehicles, and smart cities? I guess all these industries that she has mentioned are always going to talk about compliance issues. Like, no government would ever want this data to be outside, and this kind of, I mean, first of all, of course, what ways can it revolutionize it? And a sub question, sub part to that is, what strategies do developers or should developers pursue in kind of solving these challenges or preparing for these challenges?
Yeah, I mean, I look for healthcare and autonomous vehicles, and not only do you have compliance issues, but you even have essentially the risk of a person dying, right? You have actual human cost to like bad connectivity. So a large amount of the service or capability is going to have to stay as close to the patient as possible, right? So you want a lot of that to be in the hospital or in the vehicle. You don't want all the AI to be offloaded and then have your mobile connectivity drop, and then all of a sudden your car can't drive anymore. So a lot of that will have to be on the device. But what it does allow you to do is think about data aggregation and decision making in a very different way. So an autonomous vehicle, I think, is a good example here. So the driving of the vehicle, obviously you want that inside of the car. But what about things like traffic, or what about vehicle to vehicle communication, so that I can understand what's going on in the vicinity and make smarter decisions? What if another car could actually warn me about children playing near a street before I even get there? That's extremely valuable information. And so you can aggregate that at a block level or at a metro level and disseminate that if you have this edge-based access and edge-based computing capability. So it really allows you to think about new paradigms, and it's not just autonomous vehicles. I think it's really for anything. You might have all sorts of decisions being made in a metro area. Smart cities, again, um, a really good example of a process which has different capabilities to aggregate things at a different level. But smart cities, you could also take that and turn that into smart factories as well, or smart supply chains as well, right? Being able to aggregate things at different places, at different locations, um, provides new types of topologies for these applications. And then for healthcare, because we did talk about compliance, you also need to think about things like privacy. So being able to think about, what's the risk level for exposing, this patient's personal information to somebody else. A lot of AI today, especially SaaS type AI, has to run in a specific region. But in the future, again, you'd want that to stay as close to the patient as possible. Now, sometimes, just like um, a person's blood might have to go to a lab. It might have to be aggregated in a metro level in order to have the type of processing required in order to make that decision, an AI inference model, as an example. But those are decisions that can be made based on these new distributed architectures and these new distributed topologies.
True. And I mean, also kind of puts up the question of reliability in picture. As soon as we are talking about distributed and low latency networks, however, every time we are thinking about such distributed problems, there is also that factor of reliability which is coming into picture. Earlier or in current paradigm of cloud computing, where it is more about server client architecture, wherein there is this central node that you have, because the data or the network the data is hopping various nodes in network. The more the nodes, the more the probability of losing that connection. Primarily it happens at the last mile, but if we need to build a resiliency in network, we kind of start tackling it at closer to the edge. And but does it really solve the reliability issue, or I mean, are there instances or studies that you are coming across that no, it doesn't?
Yeah, I think that there are, so again, I'm not going to say there are no problems that still need to be solved. There definitely are. But if you take a look at resiliency and how, big companies solve this problem of, single point of failure, the more locations where they can put that, the better, right? And anybody who's worked with Kubernetes over multiple regions and has done, um, DR strategies using things like containers, the ability to have those in multiple places really gives you a better failover and a better capability to sort of scale up and scale down according to that as well. If you take a look at Akamai, Akamai's network that they've been building for the past 25 years, um, while it's primarily been built for content and caching, first of all, content and caching, again, the likelihood that object isn't available for downloading is very low because it's not just a single cache, right? It's a global cache. So you can quickly hop over to another cache in order to grab that object if one of those is down or unavailable or overwhelmed. The
Right.
next one is DDoS protection. So um, Akamai has DDoS protection, but that DDoS protection is based on having like multiple nodes and the ability to put traffic across this global architecture in order to handle DDoS. So in terms of resiliency, I think the more nodes, the better. You know, I it's like you can either have one animal versus a gun versus a swarm of bees versus a gun, right? It's hard to kill a swarm of bees with a gun,
Exactly.
and that's really what this is. It's just sort of like this swarm of capability at the edge, which is going to provide additional resiliency once we solve the problem of how to manage those nodes.
True. That's interesting. So let's talk about the challenges in bringing such a distributed system online. I mean, what are the challenges that, first of all, building such a network, and second, thinking about building products on such a network?
Yeah, well, certainly building the physical infrastructure of that is very difficult, and again, lucky for us, we've been building it for our own services before we, have started launching these distributed services. But the other issue, as I mentioned, is the management of that. And although CNCF, the Cloud Native Computing Foundation, is doing a lot of work in that space in order to reduce complexity and doing multi-cluster management and distributed management of nodes, there's still a lot of work to be done there. I think for Akamai, what we're looking at is how can we automate that for the customer? So how can we um, sort of change from a content delivery network, change these nodes from content delivery networks into compute delivery networks? Can we cache containers at the edge? Can we dynamically spin these up and scale to zero when they need be? Can we manage the traffic from, if you're running one node in Chennai and one node um, in Dubai, even, can we, if one is missing, can we dynamically route that to the other with minimal impact? Yes, you'll have increased latency, but better to have a degraded network than no network at all. So there's a lot that needs to be done there. So that's certainly complex. In addition, there are new technologies coming online to help out. So containers are great, but containers themselves, when compared to WebAssembly, as an example, are still quite heavy. So WebAssembly for us is um, a huge tool that's going to allow us to break down some of these barriers as well. They're more secure. They run in a native fashion wherever you want to run them. So, and we can dynamically spin those up much faster. So being able to have that capability to have those at a core center or at a distributed center or at an edge, or even going beyond that edge access and moving that to a device. So at KubeCon in Salt Lake City late last year, we had a great session that we did with Adobe. Adobe was doing a POC around a WebAssembly, and they were running it at an edge access point. And in the words of the lead engineer on that, um, if he can run it on someone's browser, he will. But if he can't, he'll run it at the edge. And WebAssembly actually gives you the capability to do both. You can actually just push that model to a browser, or you can run it at the edge.
And that's, I believe, that's where the and where every application developer is nowadays also talking about. I mean, I've been listening about WebAssembly, that WebAssembly is about to come more than 10 years from now, I guess, almost.
Mhm.
And this is, I guess, the technology is at the right inflection point where WebAssembly can actually start impacting with productive applications wherein AI is now also thinking of coming to it.
Yeah, we're working with this amazing partner named Fermion, and they have an open source project called SpinCube. And working with them has been fantastic. They've really brought us all kinds of new ideas and new concepts for exactly how that would work. Using WebAssembly in order to run AI inference. That's going to be a massive thing moving forward, because it does give us capability to put that AI inference anywhere. And I think that AI will also be a tipping point for distributed architectures.
So much important these days. I totally agree there. And I mean, we also run a bunch of AI workloads for us, and we always kind of find that we are generating things on our end, and then it has to distribute everywhere. So think about local. However, all our customers, in a certain sense, want their content immediately.
Yeah.
Taking the AI to them is going to be far big of a personalization boom rather than keeping it centralized and locked in a single place.
Yeah, absolutely. And in particular with the rise of like agentic AI moving forward as well, right? To be able to put that agent that's working on your behalf as close to you as possible is extremely important, because it's going to be aggregating, AI, what they call AI skills, which are just different AI capabilities into one place. And having the aggregation point closer to the user, again, decreases round trip times to all these different AI agents that might need to be coordinated.
So, if we talk about the edge computing from a point of view for again developers or coders who have started their career right now, so what industries should they be looking at nowadays where you think that edge computing has started to deliver results? Because as far as I understand, companies are slow to adopt, have been slow to adopt for edge computing.
Yeah, yeah. First of all, you're right. They have been slow to adopt, and unless they're using some sort of platform as a service, like you could argue that media companies are already using it, but they generally use it as a service, right? That's already done for them. Um, so certainly, media, gaming are two early adopters in this space, because in fact, I don't think I've ever met a user as passionate about latency as gamers. Um, you know,
So
the, uh, you're right. It's extremely important for them, and for media, right? Nobody wants to have the little spinner that used to be on all the media all the time, where you would have to wait for something to buffer before it would start playing back. So those are certainly two industries that are early adopters, but more and more we've sort of seen that pull through into other industries. Um, Retail, absolutely, because customer experience is so important. And then also a lot of organizations are looking at unifying customer experiences between in-store and online. Uh, the other one would be, which might be surprising because they tend to be a technology laggard, would be manufacturing. Manufacturing has a great deal of IoT, and especially in terms of sort of just in time manufacturing. being able to see the end-to-end supply chain for that is extremely important, and to be able to do that in real time is extremely important. So manufacturing, utilities, those are heavily companies that are heavily invested in IoT, and will get great value out of aggregating information from those devices at a regional or metro level. And then from there, you'll probably only then start to push into other industries. I think financial services and healthcare will get a great amount of value out of it. However, those organizations have additional hurdles, right? You really need to think about how those things are architected to comply with the local regulations. And unfortunately, we don't have like a single global regulation to comply to. You really need to think about how that works in pretty much every country individually.
Right, right. And moreover, these regulations, because they are for the benefit of end user, they tend to be far more difficult. Taking HIPAA, for example, I mean, one of those regulations wherein it really creates that walled garden for new entrants or new incumbents to be able to comply to such difficult ones.
Yeah, look, I mean, there will certainly be some early adopters in healthcare and financial services. I think those organizations that are exploring now and that can do the due diligence to make that happen will definitely get huge benefits out of it.
Definitely. So, so I mean, what would you, in a way, tell or pass a message to developers and businesses? You know, or even let's first take the case of businesses to overcome these challenges, and yeah, let's first discuss that, and then we'll come to startups.
Yeah, so I think any business will have to think about what it is that is important to them. Actually, you could probably genericize this to sort of any investment in a technology, which is what is the goal? What is it you're trying to achieve out of using this technology? One of the bad things around the hype around AI is a lot of organizations feel like they need to invest in it, even if they don't know how they're going to use it, and that leads to a lot of wastage. Organizations need to understand what the goal is and what it is they're trying to achieve. So let's say you're running a retail e-commerce website and you're struggling to squeeze, you know, 10 milliseconds out of a particular process. If you know about things like edge computing, you can say, well, it's easy. I can actually get you 40 milliseconds just by moving this closer to the user. So we don't need to worry about squeezing out, 10 milliseconds when I can get you 40. But if you don't know why you're doing it, if you don't have a reason, there's honestly no reason to look at that except just to know about it. And I think that's important. I think understanding the landscape of technology and what's possible or what might be possible is really what you need to keep in mind. So if you don't have a specific goal, just keep yourself educated on the latest technology so you can make a smart decision when it affects your business. If you don't keep up with it, if you don't keep up with the latest technologies, even if you don't have an immediate use, you're going to be at a disadvantage because you're not going to know when specific constraints have been lifted from your technology team, and you're not going to understand what is possible to do or the amount of influence that a particular technology or topology in distributed computing's case is going to have on the organization.
So over here, Abhishek has asked an interesting question here. What are the key security risks that are unique to edge computing, and how can they be mitigated effectively?
So, I mean, the security risks for edge computing are really the same as they would be for any computer application, right? You need to think about your APIs, how they're secured, how they're monitored, how they're observed. I think the key risk for security is just a poor understanding of the topology and a poor understanding of and the complexity involved in deploying those applications. So for me, one of the key goals is to automate a lot of that and to simplify a lot of that, right? So simplicity of architecture and simplicity of implementation means simplicity of security as well. So trying to simplify that as much as possible. Um, and again, I would compare it to sort of any other cloud-based implementation that most security issues have to do with configuration, like that poor configuration. So having strong processes in place to control that configuration and check your cloud posture, which includes your edge posture, is extremely important.
So, if we talk about in the same context, if we talk about figuring out what is essentially monitoring breaches, so won't that be a lot more difficult when your application is too distributed, like is using edge computing to a larger extent, wherein the data can get exposed and you won't even kind of know that it has been exposed.
Yeah, absolutely, right. So it is important to again have strong, API security, right? So looking at your API endpoints and understanding how those are developed. The great thing about like an API security product, and again, Akamai is actually a leader in this space as well in terms of API security, is it is based around your endpoints specifically, which are your entry and exit points. It's not dependent really on your topology. It's not dependent on um, the underlying infrastructure, right? So you need to think about your security in different levels, right? There's the security of your infrastructure. There's the security of your Kubernetes platforms, right? So there's the security of your platforms, the security of your application, and the security of your APIs. So you need to think about those things at all those levels. Again, the great thing about it is if you have everything properly set up on the cloud, Kubernetes, and application side, then it's really just the API side that gets exposed at those edges. And so that's really what you need to concern yourself with.
Right. And that's where platform products are gonna kind of change the landscape in a certain sense or make it far more easy for organizations and developers, I guess.
Yes, yeah, absolutely. I mean, I think that the underlying infrastructure security is a very well-known space now. There are lots of great tools around that. The API security space, there's a lot of great tools there as well, including Akamai's. And on the application space, it's something that developers have been working on for a long time. The entire move around shifting left and the entire move around DevSecOps has done a lot to put processes in place to keep those in check. Right now, I think the complexity lies a lot inside of Kubernetes and the Kubernetes platforms that are running there if you're running cloud native services. But that is getting solved by the Cloud Native Computing Foundation. So the last couple of KubeCons that I went to have been very focused on reducing complexity and making that easier. So so I'll be at KubeCon London in a couple of weeks, and I expect the same. They're going to be talking about how to make it easier for developers and platform engineering teams to manage Kubernetes, and they're going to be talking about how do we reduce complexity of Kubernetes to make it safer for people to deploy and make it easier for those platform engineering teams.
Right. And there's another interesting question from Gurpreet here. Like, will the edge computing industry be significantly impacted, or how would it be transformed with emergence of satellite internet technologies like Starlink?
Yeah, I mean, so things like Starlink are more about access. Unfortunately, the speed of light has a limit, and the latency is much lower if we have capability at an ISP, right, which has fiber connected to it. Um, I'm not saying that satellite capabilities, and things like Starlink and its future competitors aren't going to be important, especially for those locations which don't have access today. Yeah, it might make sense to have some computing capability there, or as we expand throughout the solar system, having satellite capabilities. So we have, again, it wouldn't be great latency, but we'd have a capability to have services on the moon, things like that. I think are worth considering when we're thinking about sort of like a broader view around how do we overcome the limitations of the speed of light in order to have services available anywhere.
That will go into quantum, I guess. So when you don't understand anything, it's quantum for you.
Yeah.
So great. So great. Thanks a lot for all these insights, Jay. One quick question is that I had personally was like, how would a new developer or a developer who is planning to build his or her own startup, how should they start seeing or leveraging edge computing in thinking about their next big idea?
Yeah, I mean, I think that, well, first of all, don't start with the technology, right? Start with the problem. So have some, have some empathy and think about, who you're solving for and what kind of problems you can solve for them. But I think it's more about keeping these types of technologies in mind. So, if you are thinking about, providing services to a particular region or a particular type of user, is your service doing the best for that user, and how close can you get that service to the user in order to provide them the best type of experience? Some things don't need low latency. Some things can actually run in a core data center, and it might be simpler to administrate if it's all in one place. But I think any user-focused or customer-focused application should be thinking about being as distributed as its users are. You need to be everywhere that user is, and provide great capabilities, and really think about um, how your service can keep give them low latency, or give them more privacy by running locally, or aggregate data at different levels in order to increase the value of the service that you're providing. Or um, the other direction is, being able to have that service run close to where the data is created. So sometimes it's created by human beings, but sometimes it's created by devices. So the closer you can get the service to each of those things, the more you'll be able to react to those in real time.
Right.
I think that a lot of architectures today are really built around where data is stored. Future applications are definitely going to need to be built around where data is created.
Definitely. So, to make it a full circle, I guess, what resources or communities would you recommend for developers to stay ahead in this, rapidly evolving field in a certain sense?
Yeah. So first of all, think locally. Like, try to find like every user group that is local, and so because I don't think, even though we have tools like this, where we can talk over long distances, being able to talk to someone in person is a very different prospect. So try to find local communities where you can catch up in person, get to know people, have common passions, find your co-founder in your startup, those sorts of things. In terms of the types of technology communities you should be looking at, I'm a huge fan of CNCF. I love the work that they do. I love their philosophy around not just technology, but around community and community involvement in shaping that technology. So I think that's important. Linux Foundation, of course, is a great community to get involved in as well. And because there are different aspects in each of those communities to get involved in. You can get involved as a learner, you can get involved as a developer, you can get involved as a participant, because they have architecture groups that you can actually participate in, and shape that specific community. So definitely look for those opportunities. But again, over that, just find something local, find something where you can get involved in at a human level.
Right. I mean, having that connect is how you learn a lot better than probably just reading around here and there and thinking
That's
what
right.
is
Remember that like all of us are smarter than any one of us, right? So go and take advantage of that.
definitely, definitely. So, what will be your message for next generation of developers? I would say
Yeah, so I mean, I already talked about empathy. Empathy for users, I think, is key. That's the only way to solve problems is understand the problem that you're trying to solve and who's going to benefit from that. Um, One, that I think is really key for me and that is, worked for me through my career is curiosity. I am really driven by it. I think about it all the time. I wonder if I'm stretching myself enough or if I'm learning enough. So always be curious about technology, even if you don't think it applies to you. Even if you don't think you have an immediate use for it, um, go and find out about it and pursue that. A lot of times people talk about um, finding your passion, but if you're curious, sometimes your passion can find you. So I think that's really important. And curiosity, will also introduce you to other people with the same sorts of passions as well. So I would say that is what really has driven me.
and just to add to that, I guess what I can say to the fellow developers and the community is like till the time you would stay curious, you would keep doing a lot of different things, and at that time you might not think me, or you might think that I don't know if it's ever gonna be of any help or use for me. But like Steve Jobs said, right, you will always be able to connect dots while looking back. So, with that, thanks a lot for your time, Jay, and thanks a lot for this quick masterclass and sharing your insights about edge computing for
Great.
our viewers.
Thanks, Ramesh, and again, thanks to DevBytes, and thanks to everybody watching.
Thanks for that. And so, all my viewers, all the viewers of DevBytes, if you enjoyed this, hit that like button or just send a high five on the comments. And if you didn't, just pretend that your internet went down. So thanks a lot, everybody. Thanks for joining in, and see you next week, next time with another Tech Talk by Dev Bytes.